In my previous topic, I have introduced the derivative using the difference quotient to find the slope of a curve at any point in the curve. So let's consider this equation. So the function of x is equal to x cubed plus 12x squared minus 3. So let's try to find the derivative using the difference quotient. So the formula is f of x plus h minus f of x over h. So we will just plug in the values of x plus h in here and in here. So that would be x plus h cubed plus 12 and then x plus h squared minus 3. So minus 3 minus the function of x, which is all of this. So minus, I'll just use the other board, the whole of this x cubed plus 12x squared minus 3. So that's all over h. So if you get, so you have to multiply x times h 3 times. So x times h, x plus h times x plus h. So that would be x squared plus xh plus xh plus h squared. And then you have to multiply again by x plus h. So x cubed plus x squared h plus this is 2xh. This becomes 2xh. So this is 2 times xh squared. So we go to the other side, x times h times x squared. So it will be here x squared h, and then this one times this one. So this is h, 2h squared x, 2h squared x plus h cubed, and then we add, so h cubed plus 3x squared h plus 3x h squared plus h cubed. So that's when you multiply x plus h to the power of 3. So I will rewrite that one in here, x cubed plus 3x squared h plus 3x h squared plus h cubed. So and then we have to square this and then multiply by 12. So x plus h times x plus h, that would be, I'll just copy this one, x squared plus 2hx plus h squared, and then you multiply that by 12. So that would be this one. So plus, so this is 12x squared. This would be plus 24h 24xh plus 24xh plus 12 h squared. So this is only up to here. I need to erase this one. So it's up to here, minus 3 minus 3, and then this one negative, we have to set to distribute to each and every one. So this becomes minus x cubed. This becomes minus 12x squared minus 12x squared. This becomes plus 3 all over h. Now we can cancel out x cubed and negative x cubed. 12x squared and negative 12x squared. What else? Negative 3 and plus 3. And that's it. So if we will just rewrite only the ones that are left. So 3x squared h plus 3xh squared plus h cubed plus 24xh plus 12h squared. Yeah, please bear with me, and we will be doing a shortcut of this one. So all over h. So all of them have an h, so we can factor out the h. So if we have h, here is h. So here we only have 3x squared plus 3xh, so we deduct 1h plus, so h cubed minus h is h squared plus 24x plus 12h squared all over h. So h and h will cancel out, so that will what have left is this one. But if you remember, when we do the product difference quotient, because we are looking for the slope, we will get the h approaches 0. So this becomes 0. This becomes 0. Everything with h becomes 0. So what you have left is 3x squared plus 24x. So this is your product difference quotient. Now let's compare this one from the original equation. So the f of x is x cubed plus 12x squared minus 3. Now when we did the derivative f prime of x, this one, it's become 3x squared plus 24x. Now if you will notice, the 3 went in the front, like it went down, and then the cube was subtracted by 1 power, so cube became squared, and the same in here. So 2 was brought down here and multiplied to 12, it became 24. So x squared minus 1 power, it becomes x. Now considering 3, actually 3 is 3 times x to the 0 power. X to the 0 power is 1. So this 3 is actually this one. So if you do the derivative, so the 0 goes in front of 3, and then it becomes 0 times 3, times x. So 0 minus 1, so this becomes negative 1. But since this is 0, you multiply it to this one, is still 0, so your 3 has disappeared. Now, we can have now a formula or shortcut. So if you have an f of x of like x to the n, so the derivative, the shortcut is becomes n times x to the n minus 1. So this is your shortcut. You can use this shortcut to get the derivative without going through all these computations. We can use this is called the power rule. We can use this one to find the derivative. Now we will solve some examples of other possible types of equations. So example number 1, the f of x is equal to 2x to the 5th minus 3x to the 4th plus 7x cubed minus 4x squared plus 5x minus 2. So what will happen? So we bring down 5 in front of 2. So 2 times 5, it becomes 10x. And then we subtract 1 from 5, it becomes 4 minus, so 4 goes down in front of 3, so 3 times 4 is 12 x cubed, because we subtract 1 from 4, plus, so 3 goes down in front of 7, it becomes 21, so x cubed becomes x squared, minus, so 2 goes in front of 4, so it becomes 8x. Now here is x to the 1, so 1 comes in front of 5, still 5. And so 1 minus 1 is x to the 0. So x to the 0 is 1, so 5 times 1 is 5. So only 5, the x is gone. And like before, the 2 disappears from my previous explanation. So this is your answer for the derivative. So this is your f prime of x. Number 2. So what if your equation is in the denominator, 1 over x squared? So what we do is we put it on the numerator, but the sign becomes negative. So this one becomes x to the negative 2. So following our formula, so negative 2 goes down in front of x. So this becomes negative 2x. So minus 2, negative 2 minus 1. So actually it will become negative 2 minus 1 is negative 3. So you can leave your answer as it is, like this, or you can bring down the x to the numerator, to the denominator again, so that it becomes negative 2 over x cubed. So that's example 2. Example 3. So what if your function is a square root? So a square root of x. Now we can rewrite the square root as a fraction power, a fraction exponent. So this is equivalent to x to the 1/2. So using our formula, so f prime of x, so this one 1/2 goes in front of x, so 1/2 x to the 1/2 minus 1. So let us try to subtract 1 from 1/2. So 1 over 2 minus 1 over 1. So the LCD is 2. 2 divided by 2, 1 times 1 is 1. 2 divided by 1 is 2 times negative 1 is negative 2. So 1 minus 2 is negative 1 over 2. So this one becomes 1/2 x to the negative 1/2. Now we can rewrite this. We can put it into the denominator to make the exponent positive. So your f prime of x, it becomes 1 over 2 x to the 1/2, or 1 over 2 square root of x. You can leave the equation of like that, or you can rationalize square root of x times square root of x. So your answer will become square root of x over 2x. So either this one or this one is enough as an answer, depending on your teacher. Example 4. What if your function is a radical but with a power? So for example, x squared, 5th root of x squared. So we, similar to this one, we will convert this into a fractional exponent. If you convert this into a fractional exponent, this one becomes x to the 2 over 5. So using our formula, so the 2 over 5 goes in front of x, so that will be 2 over 5 to the times x to the 2 over 5 minus 1. So let's subtract 2 over 5 minus 1 over 1. So LCD is 5. 5 divided by 5 is 1 times 2 is 2. 5 divided by 1 is 5 times 1 is still 5, but negative. So this becomes 2 minus 5 is negative 3 over 5. So the answer for 2 over 5 minus 1, this becomes x to the negative 3 over 5. Or you can bring this into the denominator, so this becomes 2 over 5 over x to the 3/5. You can rewrite this as 5 the cube root 5th root of x cubed. So this is your f prime of x. Last number. So example number 5. If you have the function of x is equal to 3x to the 5th plus 7x to the 4th over 4x squared. So let us first consider if you're adding fractions that have the same denominator. For example, 1 over 7 plus 2 over 7, that is 3 over 7. So if you're adding a over 5 plus b over 5, you just copy the denominator and then you add a plus b over 5. So if you see a plus b over 5, a plus b over 5, you can separate a plus b over 5 as a over 5 plus b over 5. Now we can do that in here. We can separate these two and copy the same denominator. So this becomes 3x to the 5th over 4x squared plus 7x to the fourth over 4x squared. Now we can then cancel out the exponents of the of x. So this becomes 3 over 4. So 5 minus 2 is 3. So this becomes x to the third power plus, so the fraction is 7 over 4. 4 minus 2 is 2. So you have x squared. Now we solve for the derivative. So the 3 goes in front of 3/4, so 3 times 3/4 x cubed minus 1 plus, so 2 goes in front of 7 over 4, so 2 times 7 over 4 x to the 2 minus 1. Let me erase this one. So what we have now is, this is 9 over 4 x squared plus, this one will cancel out, this becomes 2, 7 over 2 x. So this is your derivative. So it's simpler because you have a shortcut, so you don't have to do the difference quotient. It's only important to know difference quotient so that you will know the principle of the derivative. This is the slope of a curve at any point in the curve. So I hope you can give a feedback if my teaching is helping out, or is there any part that is difficult to understand. Please give a feedback.